Right now, without doing anything at all, you are moving through time. You can feel it. In your pulse, in your breath, in the sentence that is already behind you the moment you finish reading it. It feels like the most certain thing in your life. More certain than gravity, more certain than your own name. Time moves forward, and you move with it, whether you want to or not. But here is the strange part. The deeper physics looks into that feeling, the less it looks like a fact about the universe, and the more it looks like something happening inside you. What if the flow you feel so clearly, that unstoppable slide from now into next, is not something the cosmos is actually doing? What if the most familiar experience of your entire life is also the biggest mystery in modern physics? Hold that thought. We are going to earn our way back to it. Think about how time actually enters your life. A clock ticking in a quiet room, an alarm that drags you out of sleep before you're ready, a birthday candle blown out, one more year folded into the past, a hospital waiting room where every minute somehow weighs more than the last, a calendar on the wall with days crossed off towards something you're either dreading or counting down to, a photograph of a face that used to be younger, holding a memory that keeps forming and reforming every time you look at it. None of these are time itself. They are shadows time leaves behind, on clocks, on skin, on memory, on paper. And yet from these shadows, you build an entire private sense of motion. Yesterday behind you, tomorrow ahead of you, and a razor-thin now sliding between them, second by second, without ever once slowing down. For most of human history, nobody questioned that feeling. The sun rose and set for everyone at once, or so it seemed. Night fell on the whole village together. It seemed obvious that time was universal. One great invisible current flowing past every person, every animal, every star, at exactly the same rate. A second on your wrist felt like it had to be a second on the other side of the planet, and a second on the other side of the galaxy. Time was the one thing everyone assumed they shared completely, even with someone they would never meet. Isaac Newton took that intuition and turned it into science. He imagined time as an absolute background clock, ticking away silently behind the entire universe, indifferent to anything happening inside it. In Newton's picture, time did not care whether you were rich or poor, moving or standing still, on Earth or drifting through empty space. It flowed at one fixed universal rate, the same for a falling apple as for a distant, unseen star. For over 200 years, this was simply how reality worked. It matched intuition, it matched experience, it felt unshakable. Then, in the early 20th century, a young physicist quietly broke it. Albert Einstein did not attack time directly. He attacked something that seemed far safer, the assumption that everyone, everywhere, agrees on how fast time is passing. And once he pulled on that thread, the entire idea of a single universal clock came apart in his hands. Picture two astronauts. One boards a spacecraft and accelerates toward a significant fraction of the speed of light, then turns around and comes home. The other stays behind on Earth. When the traveler finally steps out of the capsule, something impossible has happened. Their twin, the one who stayed, has aged more. Not because of illness, not because of stress, because time itself moved differently for each of them. The faster you travel through space, the slower you travel through time, relative to someone who stayed still. This is not science fiction. It has been measured again and again, with atomic clocks flown on airplanes, and with the satellites orbiting above your head right now, whose clocks must be constantly corrected, or the maps on your phone would drift further from reality with every passing day. Motion is not the only thing that bends time. Gravity does it too. A clock sitting near a massive object, a planet, a star, or something as extreme as a black hole, ticks slower than a clock far away in the emptiness of space. The closer you sit to something enormously massive, the more time slows down around you. Imagine hovering just outside the edge of a black hole while a colleague watches from a safe distance. To you, your own heartbeat feels completely normal. But to your colleague, your clock crawls, your movements stretch out, your final radio signal arrives more and more slowly, as though the universe itself is reluctant to let you go. Fall close enough, and from the outside, You appear to freeze at the edge forever, even as you experience your own time passing normally all the way through. If speed and gravity can both bend time, then the idea of one shared now for the whole universe starts to look less like a fact and more like an illusion, built for creatures who never move very fast and never venture very far from home. It gets stranger. Even the order of events is not guaranteed to be the same for everyone. Consider a long train moving at high speed, and at the exact midpoint, two bolts of lightning strike, one near the front of the train, one near the back. A person standing on the platform, exactly between where the strikes occurred, sees both flashes arrive at the same instant. To them, the two events were simultaneous, but a passenger sitting in the middle of the moving train sees something different. Because the train is moving toward one flash and away from the other, that light doesn't reach them at the same time. To the passenger, one lightning strike happened first, and the second happened after. Nobody made an error. Nobody's clock is broken. Both observers are correct in their own frame of reference. Simultaneity itself, the very idea of at the same time, depends on how you are moving. This is the moment physics quietly rewrites the picture. Space and time are not two separate stages that events happen on. They are woven together into a single structure, usually called spacetime. Picture a vast grid stretching in every direction, warping and bending around anything with mass, with time running through it as just another thread in the weave. Different observers, moving at different speeds, do not just see different distances across that grid. They slice through it at different angles entirely, carving out different versions of now. And this leads to one of the strangest ideas in modern physics, the block universe. In this interpretation, the past, the present, and the future are not separate categories flowing one into the next. They are all equally real, laid out together inside a single four-dimensional structure, the way every page of a novel already exists between its covers, even though a reader experiences only one page at a time. Your birth, this exact moment, and the moment of your death may all simply exist, fixed points within the block. And now may be nothing more than wherever your particular slice of awareness happens to be standing. There may be no universal now shared by the whole cosmos, only countless private nows, each one just as valid as the next, each one convinced that it alone is the real one. So if physics refuses to hand us one shared now, a harder question appears. What exactly is the sensation of flow that we all feel so strongly? If the future isn't rushing toward us and the past isn't truly gone, why does life feel like a one-way journey, from a fixed beginning toward an unknown end? Here is where the mystery deepens instead of resolving. Most of the fundamental equations of physics do not actually prefer a direction for time. Run the mathematics describing gravity or electromagnetism or the motion of colliding particles, and it works almost identically whether you play it forward or backward. And yet your experience is nothing like that. Glass shatters. It never reassembles itself from scattered fragments on the floor. Smoke drifts and spreads through a room. It never gathers itself back into a tight coil rising from a candle. You remember what happened yesterday in vivid detail, but you cannot remember tomorrow, no matter how hard you try. Somewhere between the perfectly symmetric equations and your very asymmetric life, a direction appears. Physicists call it the arrow of time, and its explanation comes from an idea called entropy. Entropy is easier to picture than it sounds. It roughly measures how many different ways the pieces of a system can be rearranged, while still looking the same from the outside. A tidy desk has very few arrangements that count as tidy. Nearly anything you touch makes it messier. A messy desk, on the other hand, has an enormous number of arrangements that still count as messy. Left alone, systems drift toward whichever state has the most possible arrangements, simply because those states vastly outnumber the tidy ones. That drift from order into disorder, from the special into the ordinary, is what we call increasing entropy, and it may be the true engine hiding behind the arrow of time. The universe, at its very beginning, appears to have started in an extraordinarily ordered, low-entropy state. Improbably tidy, for reasons physicists still argue about today. Ever since, entropy has been climbing, and that climb is what carves a direction into time itself. The past feels fixed and unchangeable because it holds a lower entropy, more ordered configuration. The future feels open and undetermined because entropy has not finished rising yet. There are countless disordered paths it could still take. You remember the past and not the future for the exact same reason a shattered glass does not spontaneously reassemble on a kitchen floor, because disorder, statistically, only grows. But entropy alone doesn't fully explain why time feels the way it feels, moment to moment, inside your own head. Some of that comes from something closer to home, your brain. Neuroscience suggests that your sense of time passing is, at least in part, something your mind actively constructs. It stitches together memory, prediction, attention, and the detection of change into the seamless feeling of a present moment sliding forward. When nothing changes around you, time seems to stretch. When you're completely absorbed in something, it seems to vanish entirely. Under extreme fear, it can seem to slow to a crawl, every detail sharpened and stretched out. None of this means physical time isn't real, but it does mean that some of what you call the passage of time is a story your brain is telling you, built out of memory and anticipation, rather than a direct readout of the universe's true clock. And then there is the deepest layer of all, the one physicists are still fighting over. In quantum mechanics, time behaves strangely compared to other quantities like position or momentum. It isn't something you directly measure the way you'd measure a particle's location within a shimmering quantum field. It plays more like a background parameter than a physical property with its own value. And when physicists try to combine quantum theory with gravity to describe the universe at its most fundamental level, some of their best equations stop mentioning time at all. Not time moves strangely. Time simply doesn't appear in the mathematics, as if, at that deepest layer of reality, there is nothing there left to move. This has led some physicists to a genuinely radical idea that time might not be fundamental. It might be emergent, something that appears only once you zoom out far enough, the same way temperature emerges from the chaotic motion of countless tiny particles. A single atom does not have a temperature. Temperature is a pattern that only exists when you look at the average behavior of trillions of atoms together. Time, in this view, might work the same way, at the deepest possible level. Whatever fabric quantum gravity is ultimately woven from, perhaps there is no ticking, no flow, no next moment waiting to arrive. Only relationships, only structure. And time, as we experience it, congeals out of that structure the moment enough of it comes together. Real at our scale, even if it isn't a basic ingredient of reality itself. It's worth pausing here to be precise about what this does and does not mean. Saying time may not be fundamental does not mean your clock is lying to you. It does not mean aging is fake, or that yesterday's events didn't happen, or that grief and memory and hope don't matter. Your birthdays are real. Your memories are real. The coffee going cold on your desk right now is real. What's in question is something deeper, whether the flowing, universal, river-like time we feel so certainly is the most basic description of reality, or whether it's a powerful, convincing pattern built on top of something stranger and stiller underneath. And maybe that question matters more than it first appears. Almost everything you feel, love, loss, hope, regret, is built on the assumption that time moves in one direction, carrying you away from what's gone and toward what's coming. If that flow is something your mind is doing, rather than something the universe is doing to you, it doesn't make any of it less real. But it does mean the most intimate part of being alive might also be one of the least understood things in the entire universe. So return to the question from the beginning. Is time a river, carrying the whole universe forward at the same steady rate? Or is it closer to a trail carved by a single walker, moving through a landscape that itself does not move at all? A landscape where every step you have ever taken, and every step you ever will take, already exists, waiting only for your particular thread of awareness to pass through it. Maybe time isn't something the universe does to you. Maybe it's something you do to the universe, a pattern your mind traces across a structure that, on its own, might simply be And maybe that is the strangest, most human discovery in all of physics. That the thing you have trusted every single second of your life, the thing that feels more real to you than anything else you will ever know, may turn out to be the one thing reality never actually promised you. If this changed the way you think about the seconds slipping past right now, that's exactly the point. Subscribe for more journeys to the edges of physics and reality. Share this with someone who needs their mind bent a little today. And stay curious, because the next question might change how you see everything all over again.